Have you ever stood by a pier or watched an aquarium tank and noticed how fish rarely swim alone? Instead of scattering in every direction, they move together in tight, flowing groups, turning at the same time as if they're sharing a single mind. One moment, they're drifting calmly, and the next they're shifting direction in perfect sync. It looks beautiful, almost choreographed, but it's not a performance. It's survival. Today we're exploring why and how fish swim in groups and how this simple behavior has helped them stay alive for millions of years, right here on History of Simple Things. Let's start with the most obvious reason: safety in numbers. In the ocean, rivers, and lakes, danger is everywhere. Larger fish, birds, and even humans are constant threats. A single fish swimming alone is an easy target. But when hundreds or even thousands of fish swim together, it becomes much harder for a predator to focus on just one. This effect is known as the confusion effect. When a predator attacks a group, the rapid, coordinated movement makes it difficult to track an individual fish. The predator sees motion everywhere, but no clear target. There's also the simple math of survival. In a large group, the chance of any one fish being caught is lower. This idea is sometimes called the dilution effect. It's not that the group eliminates danger, it spreads it out. Each fish benefits from being just one of many. It may sound cold, but in the wild, reducing your personal risk is often the difference between life and death. But protection isn't the only advantage. Swimming in groups also makes fish more efficient movers. Water is dense, and pushing through it takes energy. When fish swim together, they take advantage of the water currents created by the fish in front of them. This is similar to how cyclists draft behind one another or how birds fly in formation. By riding these tiny water currents, fish save energy and can swim longer distances without getting exhausted. For migratory species that travel hundreds of kilometers, this energy savings is critical. Now this raises an interesting question. How do fish actually coordinate all of this? There's no leader giving directions, and no fish is calling out commands. Instead, fish rely on simple rules and incredibly sharp senses. Most fish use their eyes to track the position and movement of nearby fish. But vision isn't the whole story. Fish also have a specialized sensory system called the lateral line. This system runs along the sides of their bodies and detects changes in water pressure and movement. The lateral line allows fish to feel what's happening around them, even in dark or murky water. If a nearby fish speeds up, slows down, or changes direction, others can sense it almost instantly. Each fish responds to its neighbors, and those tiny reactions ripple through the group. The result is smooth, coordinated motion that looks far more complex than it actually is. No planning, no thinking ahead, just fast reactions based on local information. Fish schools and shoals aren't all the same either. A shoal is a loose group where fish stay together but don't move in perfect sync. A school, on the other hand, is tightly organized. Fish in schools are aligned in the same direction, matching speed and movement. Schooling usually happens when danger is nearby or when fish are traveling long distances. Shoaling is more common during feeding or resting periods. The ability to switch between these behaviors gives fish flexibility depending on the situation. Another major reason fish swim in groups is finding food. A group can explore a wider area than a single fish. When one fish finds a food source, others quickly follow. This shared discovery increases everyone's chances of eating well. In some cases, group feeding can even overwhelm prey. Small fish may surround plankton, while larger species work together to herd smaller fish into tight spaces, making them easier to catch. Swimming in groups also helps fish learn. Young fish in particular benefit from staying close to older or more experienced individuals. By following the group, they learn migration routes, safe habitats, and feeding areas without having to figure everything out on their own. This kind of social learning saves time and reduces risk, especially during the most vulnerable stages of life. Of course, group living isn't perfect. Swimming in close quarters increases competition for food and can make it easier for diseases or parasites to spread. Groups can also attract attention. A massive, moving school of fish is far more visible than a single individual. That's why not all fish swim in groups all the time. Many species adjust their behavior depending on age, size, environment, and threat level. When conditions change, so does their strategy. Interestingly, not all fish are born knowing how to school. Some species develop this behavior over time. Young fish may start off swimming loosely, gradually learning how close to stay to others and how to respond to sudden movements. Experience matters. Fish that grow up isolated often struggle to integrate into schools later on, which shows just how important social exposure is, even for animals we don't usually think of as social. Scientists have spent decades studying these group behaviors, and the findings go beyond biology. Researchers in robotics and computer science have used fish schooling as inspiration for designing swarm robots and autonomous vehicles. The same simple rules that guide fish — stay close, avoid collisions, and move with your neighbors — can be applied to machines that need to operate together without central control. What looks like instinctive animal behavior is now shaping modern technology. So next time you see a shimmering cloud of fish turning in a perfect unison, remember that you're watching millions of years of evolution in action. Every twist and turn is the result of simple rules working together for a powerful purpose. Swimming in groups helps fish stay safer, conserve energy, find food, and learn from one another. It's not about intelligence or planning, it's about connection, awareness, and cooperation. In the end, fish don't swim together because it looks nice or because they enjoy the company. They do it because, in a world full of predators and uncertainty, being part of a group is one of the smartest survival strategies nature has ever created. And sometimes, the simplest behaviors are the ones that make the biggest difference. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.